Hi everyone, today we're going to be doing day 17 of Advent of Code 2023. In this video, I'll be explaining the puzzles and my solutions. If you want to check out my code, it's going to be linked in the description below, but let's start out with a time-lapse of me solving the puzzles. Today is a pathfinding puzzle, so what we have to do is navigate a lava crucible through a square grid, yet again, to get it to the end without losing too much heat. So we're given a square grid of integers. Every single square in the grid represents a heat loss value. So it's a value between 0 and 9, or maybe 1 and 9, and it represents the, basically, cost that we're going to incur by traveling on that square, and we have to get from, of course, the top left to the bottom right. So there's one catch, though, so that seems like a pretty standard pathfinding problem, but we have a crucible that can only travel for 3 blocks at a time in any given direction. So, for example, if we're heading right at the beginning, we start at this 2, then we're going to go to the 4, and then the 1, and then the 3, but after that we cannot go any further in the rightwards direction because we can only go 3 squares in any direction at a time. So after we're at the 3, we can only turn left or right, and here we can only turn right, go to the 5 if we're there at the 3. So yeah, we can only move 3 blocks at a time in any given direction. We can only turn left or right. We cannot turn 180 degrees and go backwards at any time, even if we haven't hit the 3-block limit. And we just need to find the minimum amount of heat loss we can incur. So I'm going to use Dijkstra's algorithm to solve this. If you're not familiar with Dijkstra's, I'll link to a video in the description or a link for some resources. But essentially, we're just going to maintain a queue of locations that we are currently searching through, maintain our cost as we're at that point, as well as the direction that we're currently or previously heading in and the number of steps we took. We need to maintain the step information because we need to make sure we're not going more than 3 steps in any direction consecutively. So we're going to maintain this priority queue, which is going to contain 4 pieces of information. First, again, is the loss. Second is the current location. Third is the direction, which is an integer between 0 and 3 for south all the way to east, I guess. And steps is going to be the number of steps we've taken in that direction consecutively so far. And that's going to be at least 1. If we're somewhere in the middle of the grid at the beginning, steps is going to be 0 because we haven't taken any steps yet. But throughout, as we're navigating, it's going to vary between 1, 2, and 3. Again, it can't exceed 3 because we can't travel in a direction more than 3 steps at a time. So inside this loop, this is pretty standard Dijkstra's. We're unpacking the current value. We're checking if we visited this state already. Again, the state is described by location, direction, and steps. And if we've already seen that, then we don't need to try it again. If we haven't seen it, then we're going to add it to our visited list. If we're at the end, then we can simply return our answer, our current loss. Otherwise, we're going to check in all 4 directions to see what next steps we could take. There are a couple of conditions we need to check to make sure the next steps are actually legal, though. In particular, we know what direction we just came from, as well as how many steps we just took in that direction. If that is at least 3, and we're trying to head in the same direction, then that's not going to be allowed, because again, we can't travel more than 3 steps in the same direction at a time. So we're going to continue and skip that direction as a possible next choice. We do need to check if the current direction is none, though. If it's currently none, that means we're at the beginning. That's what I set it to start as, just because we basically can go in any direction we want. We can go in any direction we want at the beginning, so the direction is none. If the direction is none, then we can do anything, so we're just going to skip all those checks again. So the second condition is making sure we don't turn 180 degrees, and that's this modulo check over here, because the directions go south, east, south, west, north, and east. So for example, if we're currently heading in the south direction, which is 0, we cannot go 2 in the next step, which is north. Same for like left and right and top to down. So that's what this check is doing. We need to make sure we're not turning 180 degrees. Otherwise, we're going left or right, or maybe straight ahead if our steps have not exceeded 3. And we're just going to calculate the coordinates of that new location, as well as making sure that's in bounds, because we can't walk outside of the square. And then we're going to compute the next, I guess, steps value, which is the number of steps we've taken in the current direction. This is just so that when we go to the new square, we will know how many steps we've taken so far and can do the checks all over again. So new steps is going to be the count of the number of steps we've taken in the new direction. If the old direction is the same as the new direction, we're just going to add 1 and make sure that it's also less than 3. Otherwise, the new steps is going to be 1 because we've taken a new direction, left or right, and then the new steps is just going to be 1 in that direction. Then we're going to add this new state to the priority queue, initializing it with the new loss, which is the old loss plus the amount of new heat loss we gain. New heat loss from stepping on the new square. And then the location of the new square, the new direction we're heading in, and the number of steps we've taken in that direction once we go to the new square. So at some point, this will break, Dijkstra's will stop, and we'll have our answer based on this condition over here. And then we can just submit part 1. For part 2, our Crucible is a little bit more finicky. It's bigger, but that also means it's a little bit more unstable. So instead of traveling for 3 steps at a time, we can now travel for 10 steps at a time, which is pretty good. But also we have a minimum requirement. So our little original Crucible was very navigatable, so we could turn it as often as we wanted. But this new Crucible has to go for at least 4 steps in any direction before it turns. So it needs to take between 4 and 10 steps in the same direction at a time, and this is actually not too difficult to modify. So going to part 2, this code basically just has a new condition to check for. So in this old part 1, we're checking for 2 things. The first is making sure we don't go more than 3 steps in a given direction, and the second condition is making sure we don't turn 180 degrees. We're going to keep that second condition here because, again, we can't turn 180, but we also need some new conditions. So instead of not going more than 3 steps at a time, we need to go not more than 10 steps at a time, and that's as simple as changing the number from 3 to 10. But also, we need to make sure that we're going at least 4 in any given direction before we turn, and that's what this condition is doing. If the current number of steps is less than 4 and we're already trying to make a turn, that's illegal, so we have to break. That's what this condition is doing. Also, we need to make sure that when we're stopping at the end, we will have gone at least 4 blocks. Otherwise, we're not allowed to stop, and that's what this additional and statement is doing. So in part 1, you can see we're just checking if we're at the end. Now, for part 2, we need to check if we're at the end and if we've taken at least 4 steps in the given direction. Or rather, current direction, so the last direction we've just been going in. So that's pretty much it for day 17 of Advent of Code 2023. I hope you got something from this video. If you want to check out my code, it's going to be linked in the description below. I have a GitHub repository where I maintain my solutions to Advent of Code. If you have any feedback or questions, feel free to leave that down below, and I'll see you next time.